Welcome everyone. My name is Oliver White and I'm your host for today's webinar. Joining us are two wonderful guests, Tal Weiss, the CEO and founder of Takipi and a major fan of Apple Strudel, and Henrik Engström, who is on our reactive monitoring team and incidentally has a black belt in karate. Today's webinar follows a slightly different structure than others. We'll actually have two parts, so if you're here just to see what reactive monitoring is all about, then part one is right up your alley. We'll start off with a quick why of reactive monitoring with Henrik and Tal and continue to an in-depth demo with Tal from Takipi, followed by a quick Q&A for any questions. This will take 25 to 30 minutes. Now, part two is for attendees that are more interested in actually getting started with reactive monitoring today. So Henrik from the reactive monitoring team will show you how to get started with the 1.0 beta through our Reactive Platform, which is the only way to use reactive monitoring, I'll mention. Then we'll proceed on to configure actor metrics, review configuration points for event thresholds, and more. We'll finish up with another Q&A session with Tal and Henrik at that part as well. So please feel free to add your questions in the panel of the GoToWebinar app. So at this point, I would like to hand it over to Henrik, who's going to set the table for us to dig into reactive monitoring with Tal. Thanks very much, and enjoy the show.
Thanks, Oliver. I'm super excited to be here with Tal and show you what we have so far with reactive monitoring. And we're going to start off with talking a little bit about why and what reactive monitoring is needed. So first of all, in a traditional application, a synchronous application, if you will, the context is automatically transferred via the stack. But with asynchronous applications or reactive applications, this is no longer true. You don't know what thread was executed before you're taking up a task. You don't know what thread the task will execute on after you've finished your job. So this of course, requires a new view of looking at monitoring. What's your take on that, Tal?
Yeah, definitely that's something that's been a big challenge for many of our customers and the users that we work with in asynchronous systems. Understanding exactly what brought you here across a distributed system, across a complicated actor hierarchy is definitely a challenge, and that's kind of one of the things I'm excited to talk with everyone on the line a bit more today, because it's definitely a big challenge that we've seen across many folks, across many verticals.
Yeah, as I said, stack traces are less useful in an asynchronous environment. So basically, if you get a stack trace, you only get it for that particular stack frame you're in or that actor that throws the exception. So it's very difficult to get any context. However, with our collaboration, we managed to actually provide you with some extra information. So if there's an exception thrown inside of the actor, we can add additional information like what actor sent the message, what was the message that caused this exception. And with Takipi's dashboard, you can get to that detail very quickly and effectively. And maybe, Tal, you can talk a little bit about how you do that inside of the JVM, how you're able to actually get that information out.
Yeah, definitely. So kind of one of the biggest challenges, is when things go awry, is to be able to get to the actual state. And the state may be asynchronous, maybe something that's, through the RP instrumentation metrics, we're able to collect, kind of the journey by which a message passes through the actor system. But then also when something, fails, such as you get a database exception or an IO exception, or even something like, events like unhandled messages or dead letters. One of the beautiful things about the technology, it operates literally between the JVM itself and the hardware. And that enables it to capture state at a very deep level, yet do so very quickly. And that also kind of will lead us to the third kind of bullet here, which is anything around performance and just how expensive these things are if you attempt to do them manually versus practically at the core level. So having the ability to both collect richer state and also do that very efficiently is really core to the solution.
Yeah, that's really one thing that blew me away when I started using the Takipi solution is like how effectively you can do this and how valuable it is to me as a developer when I try to pinpoint what's going on inside my application. So I think this is a smarter way of trying to collect the right information and a very effective way to collect information. And we'll show you later in the dashboard what it looks like. So in an async application, there's simply too much data to track. If you're trying to track everything that goes on, and you have like millions of actors and they send a lot of messages, this is very difficult. It's actually something we tried in a product called Typesafe Console, where we had the approach to track everything that was going on inside of your application. And although it's very cool, it's a very cool feature, we also realized that sometimes you need 2 times or 3 times the hardware, just to do the monitoring. So the production environment would be 1 time, and then you have 3 times the hardware to do the monitoring, and that really doesn't make sense. So you need to be really careful with what actors you select to monitor. And some questions that comes up around this topic is like what data should we keep and what can be neglected, and what should we filter out, and what should we aggregate and how should we aggregate it. And in this first version, we provide a very powerful selection module with which the user can define what to monitor and how to monitor it. And I'll go through exactly how you set that up in the configuration part later. This selection module also provides you with a way to set up thresholds, so we can actually trigger events inside of Takipi. And perhaps, Tal, you can explain a little more what's going on with trigger events.
Yeah, so first of all, your point with regards to what to keep and what to measure, especially when it comes to performance, is crucial. When you have a system that's running at very high scale and you're processing thousands to tens of thousands to hundreds of thousands to millions of messages every minute, trying to keep track of them all, and we've seen many customers try to do that, by trying to instrument every message, trying to log these things to file, and that can add tremendous performance overhead, both in terms of the CPU cost, but also as important in terms of the I/O. If you need to start logging gigabytes of disk or firing long gigabytes of information over your network at scale, that is going to cause a severe impediment to your ability to monitor the system at scale. And I think that's one of the beautiful things about this technology that we've jointly built, is the ability to track potentially tens and hundreds of millions of messages extremely efficiently, in a way that is ultra fast, just because by having that melding of the mind between both the instrumentation at the core Akka level and then the work that's being done practically between the JVM and the processor to be able to consume this information, track it, and then only asynchronously send out pulses containing the data. And then on top of that, providing both an API layer to control exactly which information you want to see and be able to dig in a bit deeper into actor hierarchies, and then on the other hand, providing an extremely powerful UI to do the visualizations and really kind of zoom in into those areas which may be affecting your application the most.
Awesome. Okay, so let's talk a little bit about the instrumentation side of things. So in this release, we have instrumented the Reactive Platform. So first of all, I'd like to talk a little bit what Reactive Platform is. It's a certified build from Typesafe with our OSS projects, and it comes with a lot of extra features. One of them is reactive monitoring. So if you have the Reactive Platform, you also get reactive monitoring as one of those features. And Reactive Platform is free to use for evaluation and development, but it requires a subscription with Typesafe if you're going to use it in production. So with this reactive monitoring approach, we are actually weaving in point cuts or call points into the Akka code. And whenever there's something interesting going on inside of your Akka application, we're going to call an SPI. And those could be things like, actor system started, actor created or actor stopped, a message being sent from one actor to another, a message being taken out from a queue, a message being processed, and so on. And based on these point cut calls to the SPI, we can then deduct information from the method calls and create metrics and events and traces and so on. We also provide a very configurable module, and I've talked a little bit about that before, and I'm going to touch upon it when we go through the configuration side of things. We track actor-specific events inside of the application. Things like exceptions, of course, but also unhandled messages and dead letters and things like that. Really ACA-specific events. And we also provide a trace module. And with this trace module, you can define a hot path, if you will, the most important part of your application. And when you define this, it's an API we provide, so you do it programmatically. And when you define this, we will gather metrics for that hop path automatically. And you can also set up thresholds for this trace span. So on that, I'm going to leave it to you, Tal, and talk a little bit about the Takipi side of things.
Cool. So let's see, perfection. So yeah, so Takipi essentially is a production monitoring tool which is really tasked with doing three key things. The first is the ability to collect highly detailed, in-depth information directly from your JVM. Going back to what I said about running actually between the hardware and the JVM itself. So that enables you to capture information that is otherwise unavailable to you by any other means. So things like knowing exactly when things break in the code, capturing information about errors, and then being able to dive in and actually see the code and the variable state at the moment of error. And then so first of all, giving you amazing visibility at the JVM level into your Scala, into your Java, and specifically here about into your Akka application. We'll show you a bunch of things around that when you go into the demo. So, and the core ability here is to know exactly when things break in production versus being reactive to it in a bad way. Having your customers call you, etc. Actually knowing exactly, when things start to break, when code begins encountering critical issues, when issues like in the world of Akka, things like active throughputs go down, inboxes start filling up, things around, being able to know that on the first level, and then that also on that kind of foundation, we have three key pillars. The first of all, the tool is built with extreme security built into it, multiple layers of private encryption, architectures for both public and private clouds, hybrid deployments, which enables the solution to be deployed in production in companies which are HIPAA and PCI compliant, major financial institutions. So a big focus, first of all, on security. The second, which I think is probably by far, maybe the most important one, this is a tool which is built for extreme high-scale, low-latency production systems. So applications that process billions of messages, every day, and the ability to keep track of those and see exactly how errors and how throughput trends are then going from macro into the actual code, into the actual variable state in real time, and doing that while incurring almost no performance overhead at a sub 3% CPU. Even at the highest max, it's something again is core to the tool, and that's what enables us to work with customers who are very, very focused on these things. And that's why, especially working, leveraging this within the context of RPM is so crucial, because Akka applications should be fast and should be low latency. That's at their core. So we want to make sure, as Henrik said, that we're able to monitor them without adding overhead. And I think that's one of the beautiful things about the Reactive Platform Monitoring solution. And the third bit is the tool is easy to integrate in the sense you don't have to change your code. You don't have to change the way you build your code. You don't have to change. You don't have to teach. The module about exactly how your application is built. It runs seamlessly out of the box, supporting OS X, Windows, Mac, Shift, Puppet, Ansible, Docker, super easy to install with beautiful support for Java and Scala, of course. So that's kind of the third key tenet of the tool, and that's why this RPM is really having these three really makes it a really great solution in our mind for running high scale production systems. So that's kind of a rough overview, Henrik, of Takipi in that sense. So
thanks a lot. I mean, this all sounds awesome, but what does it look like? Should we take a peek at the demo application and show people what it looks like?
I think so. I think now we're all engineers, and you all know the proof is always in the pudding. So let's definitely do less talking and more demoing. So if that's all right with you, I'm going to take over presenter responsibilities. So I'm going to make myself the presenter here. Okay, so I'm going to show my screen, and hopefully everyone here on the webinar end can see my screen well. Please let me know if otherwise. Okay, so I'm going to kind of show you two things. Okay, I'm going to show you kind of standard dashboard, and then I'm going to dive into a lot of Akka stuff and really touch on those points which Henrik kind of mentioned. So what we have here essentially, and what the tool does, it correlates. At the heart of the tool is the correlation of throughput. How much information is your system able to process? So throughput, and then being able to come in and then compare that to errors, because a system that is running well is essentially doing two things. It's processing massive amounts of data at a very fast pace. Your users and your customers are being well served, and it does that with a minimal number of errors and issues. Meaning, the data is being processed correctly, and that is really what is at the heart of the tool: the ability to see both errors and metrics. So when I talk about errors, I mean everything. Any uncaught exception, caught exception, logged error, logged warning, HTTP error, and then in the world of Akka, unhandled messages, dead letter, tracing events. See all of these events, and no matter if they're happening 5 times a day, just once, or 1 billion times a day, being able to visualize those without having to go in and try to trace everything and log and kind of manually sift through all these massive log files. So kind of the first view which I'm going to show is just the error view, and then I'm going to correlate on top of that as metrics. What you have here is essentially every error that's happening within your system. You can see that beautifully, and you can see exactly just looking at the past. Then you can slice and dice by multiple clusters, slice them by specific servers, slice and dice by specific JVMs and specific time frames, and then come in and see, well, show me the errors that have been happening the most today, because I want to be able to correlate them with throughput in a second, and kind of add them to the graph and show me exactly, these guys exactly how many times they're happening, each one, how many times it's happening across. This could be across one machine or across 1,000 machines. I can come in and very easily see, all these errors, and come in and focus on, just show me this guy here, and I can see exactly the contribution of this caught exception compared to the contribution of this log error, log warning. So you can see that very beautifully, and I have extremely powerful filters. For example, if I want to focus just errors affecting a specific sort of background tasks or actor, I can do that very easily. Kind of just zoom in and filter everything. Of course, will show me, kind of reflect that immediately for me. So I can do that to see exactly. Show me, did we introduce any new errors or any new issues during the past hour, day, or week? Okay, so now we're at the macro level looking at errors. And then on top of that, we want to be able to show, to correlate throughput. So for throughput, we'll see either throughput that's, kind of generic to JVM level stuff, just calls into your code. But when we're using Akka with RP, then something beautiful happens, because the actual throughput module will begin showing us extremely high detailed metrics about the operations of the execution of our actor system. So you can show me, show me all the actors that are running within my system, and for each actor, using some of the APIs that Henrik will show later on, you can actually subsegment those into specific parts within the actor system, specific paths. And you can see for each one of those, exactly how many actors are running, what's the average mailbox size, what's the maximum mailbox size, what's the, so you can visualize that, and then you can come in and look at things like actor processing metrics. How many instances of the actors are live, how many process messages. Again, these really powerful techniques, and they can enable you to ask extremely powerful questions. So, for example, I could come in and say, well, now I'm going to show me, for example, the amount of all the actors that are running, as a whole in my system. You can aggregate that data for me, so I can see different types of actors. I can see exactly how many instances. So if I see, for example, that I have fluctuations in the amount of actors that I'm seeing, it may be that I'm having provisioning issues, or that actors may be dying unexpectedly, which is also a good thing, which will also enable you to jump into the errors section in just a second. But I can come in very easily and just focus on the transaction actor. I want to say, well, show me, the transaction actor, exactly, how many times this guy, is. So you see, the bulk of the activity here within this system is really the transaction actor. So I can see exactly how that overlays with, all the other ones. I can see that the database actor, for example, add these, and see that they, on the whole, will consume a lot less. So I can very easily come in and visualize every aspect of my system. Let's talk about something, just show me how many messages, for example, I've been processing over the last day, over the last hour. So it's very easy. I can see, even let's go to the last hour here. So I can see exactly how many messages are being processed across my cluster, and then I can come in and break that down and see, well, what, show me out of that, how many are being processed by the transaction actor. So I can see that, and then correlate that with how many messages are being processed by the database actor. And this is beautiful. You're able to collect information on billions of messages, and again, with extreme performance, sub 3% CPU, a fixed I/O overhead is like sub 50 megabytes an hour. So you're able to do these kinds of things, and then you can also correlate this and show, well, has the database actor experienced any errors? So you can say, hey, actually the database actor has been experiencing some errors, and I can actually, oh my God, see a spike here. So I can come in and focus, on that spike in the errors. It actually correlates to the overall increase in throughput. So this is interesting. I see, we have more throughput in the system, and as a result, the database actor is now encountering more errors. I can see that actually during this period of time, it encountered 20 times, and that error is being experienced 20 times out of 13,000 calls into the actual actor. So this is exactly where we see that beautiful, beautiful intersection between errors and throughput. But it doesn't stop here. What's beautiful, we've only just seen the first half of it. Now comes the cool part. We can, with one click, actually zoom in into the code, into the variable state at the moment of error, right as if we were there. So we're going from macro, from visualizing things at a macro level, to actually come in and see exactly what was happening, in the code across the entire call stack, and see, all this beautiful state telling us exactly what the actor was doing. And you can see even the call stack here as it's being predefined, so all the fork futures, all the stuff, all the fork joins are kind of, filtered out by default. So you can focus in directly on our code and you see exactly, where the exception was thrown, where it was caught, so we can see this very, very beautifully here, when you can see multiple instances of that error from different machines and across different times. And again, this will work beautifully for both Scala code, but even for Java code standard. So everything will work the same. You just choose an error, you click it, and and you'll immediately be able to see all the variable state, regardless. And this is, of course, extremely important in asynchronous systems. When understanding exactly, when just knowing that an exception happened can be hard, because a lot of time it's not even happening in user-facing code, and a lot of time we'll just get very deep somewhere in log files. Versus here, you see how the system kind of brings to the surface that intersection of throughput and errors very, very beautifully and very, very richly. I can kind of see across the call stack, and go down. So once I've kind of detected an issue, correlated to throughput, I can do a bunch of other really, really cool stuff. I can, for example, come in and then with one click, open up a JIRA issue for that error, which will actually contain the complete variable states and code for that error. As a developer, for me, this is pure gold, because if the DevOps folks on the operations side have experienced something that's out of threshold, exceeding some new issues having introduced, I can with one click, directly from the JIRA link, be able to see exactly what was happening. There's also reverse integration. So if you are using logs, and I imagine many of you guys probably do, as we all do, even if you have error logs, and you have events in them that you're trying to correlate to something bad is happening within your Akka system. So, if you have, for example, something like this, you'll automatically, by having, RPM install, Reactive Platform Monitoring, every error, and then we have beautiful, beautiful support for Akka logging. Every error in your Akka error log, which up until now would have been shown something like this, just the error itself, will now automatically have this embedded tiny hyperlink that once you kind of go in and you click that, you'll be able to jump directly into the actual source code and state at the moment of error. So in Akka logging, so the beautiful thing about this solution, it also makes logging and Akka logging much richer in that respect. So your logs themselves now become kind of 10x, quote unquote, smarter, again, without you having to do anything. Again, this will work for Akka code, Java code. It will automatically kind of work for you guys out of the box. So you have and you can see all this deep, rich variable state here. There are multiple integrations and entry points. So for example, things like, you can integrate this and define thresholds, to send notifications into tools like PagerDuty and Slack. You have your own Slack channel with different alerts which you can configure. HipChat. So, the tool will integrate itself, the solution will integrate itself beautifully to exactly how you guys work. An extremely powerful alerting module, which will enable you to say exactly what you want to be alerted about and exactly by which, through which channels you want to get another PagerDuty, Slack, JIRA, and email notification. So a lot of extremely powerful tools that are built around that. And then just kind of taking one step back, again, bringing it again to that whole notion of being very easily able to correlate how complex actor and systems and Java code in general is executing at scale, seeing those metrics, and being able to very easily see how these correlate to the actual errors that are happening within your code. And this runs, this for example is one of our production clusters, and you see it's running at tremendous scale. And again, for example, you see this error here, and it has happened during the past day 400,000 times out of 207 million calls into that code, and you're able to track that again very, very easily and visualize that in a very, very easy to do manner. So a couple last things. Provisioning, super duper simple. You want to install this on your server, you just click this, and just Linux, Windows, OS X, Shift, Puppet, Ansible. So it's super easy to do. Inviting teammates, be folks from the DevOps side, who want to hook this up into their alerting system, or the engineers who want to be able to get the actual tickets or notifications. Again, super, super duper simple to do from that respect. So the tool really has a lot of features. It's extremely powerful, and especially when combined with the RP, it really shines when it comes to monitoring Akka applications at scale and giving you guys a solution that is very, very powerful. And very excited about a lot of other stuff that we'll be adding here very shortly, such as what Enric was talking about, such as asynchronous traces within the actual snapshots themselves. So you'll be able to see for each message exactly the path, and not just the thread, not just the call to JVM, but also very soon be able to see the actual tracing. That's extremely powerful to see. Even some things that we were talking about earlier on, for example, like tracing. So you can already see here, for example, traces that have been added, by using the API that Henrik has mentioned. And again, there's many, many powerful tools here. This is a very kind of broad solution, and we really look forward to having you guys kind of test it out and hopefully having it give you the kind of tools and capabilities you need to monitor your production applications at scale. So Henrik, with that, I'm going to kind of bring it over to you because there's a ton more features here, but we will not have time to cover them today. I just hope this kind of gave everybody kind of a small taste of the breadth and depth of the solution. So Henrik, back to you.
Thanks, Tal. Thanks for that great demo. I'm super excited. I get even more excited when you show me what we have so far. I think it's time to break for a Q&A to see if we have any questions. Oliver?
Yeah, yeah. Hey guys, that was great. Thanks so much for that. Um, Audience, this is the Q&A part of part one. We will be beginning part two in a few minutes. Going into actually getting started and getting it set up. So let's see. I think one question was already answered, but one attendee asked, among ACA-specific events, what does the instrumentation provide with regard to mailbox size and dispatcher operation?
Okay, so maybe I should have changed over to my screen. ACA-specific, can you repeat the question, please?
Sure. Let me. I'll switch it over to your screen now.
Yeah.
Oh, it is on your screen.
Okay. Yeah.
We're seeing your screen.
Okay.
The question was, what does the instrumentation provide with regards to mailbox size and dispatcher operation with ACA-specific events?
So right now we have max mailbox size and average mailbox size per actor. So that's it. There's no correlation to dispatchers yet.
Okay.
Yeah.
Another question, to trace the errors in the source code as Tal demonstrated, do we need to provide the source code to reactive monitoring?
So I'll take that. So essentially, the system by default, and so the question is, you don't have to provide, the source in the sense you have to provide the solution with like the keys to your GitHub repository. So what the tool will do is, by default, it will decompile the code. It'll show you, if you're using Java, it'll show you decompiled code. If you're using Scala, which I imagine most of you guys do, it's very easy to, if you're using SBT-only build system, essentially to create a source code artifact and then point the system to it, and it will then know how to dynamically pull from those artifacts the actual source code that's needed to demonstrate to show you the code itself. It only pulls the snippets which are relevant to the actual error itself, and even from a security standpoint, the information itself is encrypted with private keys, which remain behind the firewall, and there are multiple layers of encryption. Also have the ability to keep that on premise. So just from the security standpoint, but it's super easy to do. There's a ton of documentation. It takes like 5 seconds essentially to get source code up and running. And if you're using Java, then that will automatically decompile from you even without it. But you don't have to like upload your source code or something or get full access to RPM to be able to fully leverage the system.
All right. Is it possible to correlate information from multiple clustered actors? Is the next question.
Currently, no. The metrics are aggregated on the server, but what you can do is you can filter down. So as Tal showed you in the demo before, you can decide what nodes you want to see in your cluster. You can also decide what JVM you want to see data from. So in that sense, it's possible to filter, but there's no automatic way of doing it. You have to manually filter it.
Yeah, the way that it works, and in terms of with the tool right now, you have 3 layers by which you kind of you can distinguish and differentiate between different clusters. So you have the notion of an environment. So environment, that's the kind of the first level of the hierarchy, and that usually translates to something like staging versus production, or things that are usually kind of completely differentiated from one another. And then within an environment, you have two kind of switches you can control. You can differentiate between nodes and JVMs. For example, you can tag a JVM. If you have 10 machines, you can each machine, for example, is running, say, Docker containers. Each of those Docker containers is running a different kind of application. So you have the consumer, the publisher application, for example. It's very easy to tag each JVM which you launch. You just pass an argument with a tag like consumer and publisher, or a node, for example, and then through that you can correlate the data very, very easily and see exactly what's, show me all the events, show me all the actor system metrics, so show me all the errors that are happening in my system across my publisher JVMs, for example. You know, they're maybe running on multiple machines. Or you can take a group of nodes within your cluster who may be servicing a specific customer of yours and tag them. So all the all the JVMs running on those nodes would also be aggregated. So you have multiple levels by which you can group, slice, and dice the information, and then probably down the road we'll be adding a further integration that you will also, when you define logical Akka clusters, you know, have those be represented in the UI itself automatically without you having to do anything in addition. So again.
Okay. Well, there's a few more questions, but for the sake of continuing the presentation and going into part 2, I'm hoping that we can get to those later. For our audience, I'm going to pop up a quick poll to give, if you'd care to give a little feedback, what you think so far of reactive monitoring, what you've seen today. It'd be helpful for you to fill it out. I'll leave it up for a minute or two while we prepare for part 2. So perhaps we can also have another question here. Yes, we do have. Can metrics be shipped to statsd/graphite, or is it tightly integrated to Takipi?
Sure. You can actually, one of the beautiful things about the technology is that it compresses those metrics into pulses, and then you can essentially, you have a very powerful configuration UI system by which you can fire that into Graphite or into any other tool which you want to integrate with. And the beautiful thing about this, then instead of now, if you were to try and come and fire that information manually, you'll be sending gigabytes of data. That information is compressed and indexed by RPM in real time, and then you can, and that information is then not just available to you through the compressed information, not just through the RPM dashboard, but you can also integrate that with a Graphite or a PagerDuty, and the beautiful thing about it is you can do that at literally 100x less. It's like at 100x faster the I/O speed in terms of the compression that's happening. So you can totally do that, and we have many customers who do.
Okay. Excellent. All right. Well, I'm going to take the poll down now. Henrik, we're back on your screen, and this is where Henrik is going to display how to actually get started with the 1.0 beta using Reactive Platform. And then we'll dig in a little bit more towards the actor metrics and some of the other configuration points. Am I correct there, Henrik?
Yeah, you're absolutely spot on. Yeah.
Well, then I'm going to mute my loud mouth and hand it over to you.
Thanks. Okay, so yeah, as Oliver said, we're going to talk a little bit how you can sign up for the reactive monitoring beta. And I'm going to explain a little bit about the monitoring architecture, how you can install this on your machine. Tal already touched upon that. And then we're going to talk about how you should configure, or how you can configure your system. I'm going to show you the Trace API, and after that we'll have a Q&A if you have any more questions. So the easiest way to get started with this is to actually surf to our tech blog at typesafe.com. And you'll find this great blog post written by Oliver explaining, the introduction about reactive monitoring. And in this blog post, there's a link, and if you click on that link, you'll get to this page where it explains a little bit about the beta program, and you fill out your name and information here, and there will be an email sent to you. Inside of that email, there will be a link to the documentation. And when you go to the documentation, that will describe exactly what you should do to get started. And let's start off by looking at the components here. So the components of the architecture, it's a highly modularized architecture that we've designed. And as I've said before, we base it on the Reactive Platform. So Reactive Platform is a must to get onto monitoring. And what we do is, I touched upon this earlier, is that we have this instrumentation SPI. And basically what's going on is that for everything that's happening inside of your Akka application, we call this SPI from these poncots. And then we have, on top of that SPI, we have an implementation of that SPI called Cinnamon. And Cinnamon consists of a couple of components. And the actor selection is the main one, and that's where you define exactly what you want to monitor inside of your system, and also how you want to monitor it. And based on that information, we can then in the metrics module gather metrics automatically, and we also keep track of the events for the monitored actors. And we also have this trace module that enables you to define your hot paths inside of your application. So the three parts that this consists of is Reactive Platform and the Cinnamon modules, and finally on top of that we have the Takipi integration. So we call on every you'll install the Takipi agent on every machine, so that will run locally, and we will call this from Cinnamon. We would call the Takipi agent and say, here's a piece of information, and then the agent will gather that information and send it off in pulses. And that's highly efficient, as Tal explained before. So it won't have a performance impact on your production environment. So the next part is the Takipi dashboard, which we've already gone through, so I'm going to skip that and then show you what you need to do to get started. So basically, this consists of three pieces: the Reactive Platform, Cinnamon, and Takipi. And the Reactive Platform, it's free to use during development and for evaluation, but as soon as you move into production, you need to have a subscription with Typesafe. One of the pieces that you need to do in order to use Reactive Platform is to sign up for an account at Typesafe. So you go to typesafe.com/account/register, and you enter your information here, and once you've done that, you'll get a developer license ID, or you have a login, and from that login, when you log in, you can click on this Get Developer License ID, and that's like the key that you should use inside of your application, which I'm going to show you in a bit. So right now, the two supported versions of Akka and Scala is Akka 2.3 and Scala 2.11. That's because Reactive Platform supports those. So we will follow, Reactive Monitoring will follow Reactive Platform. There's no Akka 2.4 yet, but as soon as there will be a Reactive Platform for Akka 2.4, then Reactive Monitoring will be part of that as well. So when you have the subscription ID, basically you need to configure your application a little. The first thing is that you need to create a typesafe.properties file inside of your project folder. And once you've created this file, you need to provide your subscription ID with this syntax here. You have the key typesafe.subscription and then your subscription ID. It's good to point out that this is your subscription ID, so maybe you want to add this to your git ignore if you're using Git, so you don't commit it to the repository and everyone will use your subscription key. It's just a good to know thing. Another thing that's required from your project is SPT 13.7 or higher, so please make sure that you're running a valid version of SPT. And then finally, what you need to do inside of your application or your project is that you need to make sure that you're using the Reactive Platform. And we have provided a plugin that will rewire all your dependencies to ensure that you're using the Reactive Platform versions. And you do so by adding another file called typesafe.spt, and that should be inside of the folder project/project. It's good to realize that it's two projects here, so it should be project/project and then typesafe.spt. And then you add this information here. Now, if you've already used Reactive Platform before, then you're aware of this. The thing to highlight here is that the version we're using is actually called something else than the standard Reactive Platform version. The standard one is called 15v09p01. But we're also adding -instrumented-01. And the reason for this is Actually, reactive monitoring is not yet part of the Reactive Platform. It's a separate branch. Once we have it integrated into the master branch, then you'll use the standard notation. But for now, it's very important that you actually use the instrumented version, or else you will just use the plain Aqua version. Okay, and there are some limitations. I won't go through them right now, but if you're interested, you can read the documentation for that. The next piece that you need to do is to ensure that you're using the cinnamon modules. And the way you ensure that is to actually add the library dependency in your project, in your SPT project. So basically just copy paste this line here and put it into your build.spt file, and you'll use the cinnamon modules automatically. Now, even though, so that's all the pieces you need to do in your project to get started. It's very important to highlight, though, that even though you've set everything up like this, no actors will be monitored automatically. And it says a note, and it's highlighted, but I'm guessing that people will run into this issue anyhow. The reason that nothing is monitored, if you're only setting up the dependencies, is that you need a configuration file that describes what you want to monitor. As I mentioned before, we had the approach in previous projects where everything was monitored by default, and this would cause, you know, a lot of traffic being handled by monitoring, which would eventually make monitoring fall over. So we encourage people to actually think about what parts they want to monitor about the application. Okay, and then the final part is that you need an account with Takipi. So basically what you do is you go to takipi.com and you click the sign up button here, and you'll get a login. And when you have that login, Tal showed you before that you can install the agent. It will give you scripts to install for the different platforms. So if you're on OS X, there will be one script, and if you're on Linux, you can use wget or whatever. So once you've installed Takipi, you've signed up for Takipi, and you've installed the agent on your local machine, then you need to invoke it. It's and you do so. It's a Java agent, so you use the agent lib -agent lib command like this. If you're running an SPT, which I guess you are, then you can use this command to just start it from the prompt, from the terminal. Or if you want to add it to your build file, then you can do so by adding these two lines. So you make sure that you've worked the run, and also you add this Java option line or command. And finally, if you're using SPT native packager, there are some instructions for how to add, so it would get added when you use the dist command.
Yeah.
Okay, so that's kind of the setup of things. Let's take a look at the configuration side of things. And here we provide multiple ways. The first thing, as I said, is that you need to think about what you want to monitor, and that's the actor selection. And the actor selection provides two ways of defining what you want to monitor. You can use your classes. That's called class selection. And basically what you do is you can, say this actor class example.a.a should be monitored. And you can also use packages for this as well, which I'll show you later. But you can also use path selection. So that's the actor path. If you're preferring to use that notation, you can do so as well. We also provide a wildcard selection. So I want to monitor all the actor classes inside of my package A. That's how you do that. And the same goes for a path using actor path. So wildcard notations. So now we've defined exactly what we want to monitor. The next step is to define how we want to monitor things. And for that, we have this report by setting. And report by setting currently supports two different values, class and instance. So if you decide to define a report by class, like in this example here, then that means that regardless of how many instances you create, how many actor instances there are of this actor class A, there will be only metrics gathered on the class level. So this is a very powerful way of gathering metrics if you know you have a lot of instances. Not all the instances are traced by default, or metrics are gathered by default. And for example, in demo application, you had this transaction actor, which had 27,000 instances, I believe, running actors. And what we've done for that is, of course, to use the class notation. We're only interested to gather metrics on the class level for that, because that's much more efficient. On the other hand, Tal showed you for the database instances, we use the instance notation, which basically means that you can drill down into the specific information per instance of that actor. And that could be interesting in some cases. So we provide both those ways of setting up your system. So now we've defined what to monitor and how to monitor. And you can also use this exclude syntax to exclude things if you're using the wildcard notation. For example, if you're saying all the actors inside of this package except these actors. So that's also a way to define what you want to monitor. So we have what to monitor and how to monitor, and then we can also provide additional features on top of this. And that's metric thresholds. So metric thresholds, you can define limits inside of your application to get an event inside of the Takipi dashboard when those limits are breached. And right now we support mailbox size, mailbox time, and processing time. So, and the syntax is like this. You say, for this particular actor instance here, I want to set up these thresholds. So the mailbox size shouldn't be larger than 1,000. The mailbox time, which basically means how long the message is inside of the actor queue, shouldn't exceed 3 seconds, and the processing time of the messages should be no longer than 500 milliseconds. If they breach these thresholds, then an event will be created inside of the dashboard. Or actually, we're generating one, and the agent will make sure that that information is transferred to the dashboard and it's shown there. Okay. And finally, we have a fallback mechanism. So basically, if you have a hierarchy of classes in this case, then the values of the thresholds are inherited, and you can override those values by defining, finer-grained limits lower down in the hierarchy. And it's explained here. I'm not going to go through that in detail. So that was the configuration part and how you define what and how to monitor things. I'm going to move on and show you the trace API. So the trace API basically provides a mechanism to define spans over multiple actors. So let's say you have a hot path inside of your application. Maybe there's some stock trading going on that involves a couple of actors, and you want to ensure that the metrics for this hot path is behaving according to certain rules. So you can define a trace span for that mechanism, because what I've shown you before is only per actor class or per instances, and this provides you with a mechanism to gather information over multiple actors. So we have this tracing API, and it's an extension. It's an ACA extension, and what you need to do is basically you import this class, this tracer class, and then you provide your actor system to it. And when you've done that, the next thing to do is to call this start method, and you give the span a specific name, and right in this example is my trace name, and then you do something inside of this inside of the function here, and we describe how you do it in Java as well. So both Scala and Java is supported, of course. So that's how you start the trace, and then on the other side of things, when you want to stop it, you call the end method, and with the same name of the trace. So the name is the key. So it's important that those match up. And here's an example for how to do it. It only involves two actors. We have actor A and actor B, and actor A inside of the receive block here. When someone calls it with begin, then we start this trace called my trace name, and we call actor B. And if we look inside of the receive block of actor B, then we do some work, and then we stop this trace. So the metrics gathered for this will be including both those traces inside of those actors. And finally, we provide a way of defining thresholds for your spans. So you can say, you know, for this particular part of the system, it should never exceed 5 seconds. So that's like the hot path. And if this is breached, then we will, similarly as before, create an event, and you'll see it in the dashboard. And I guess that's it for me, and we can move on to Q&A if there are any more questions.
Henry, just let me add to that, that with regards to installing the Takipi agent, there's a ton of documentation on that for all the different configurations, all different environment kinds, you know, all forms of IE automation, again, from Shift to Puppet to Ansible to Docker to SVD. So all these things, we can post a link to that somewhere later. There's a ton of information that's accessible both within the dashboard and from docs.takipi.com to help folks get started with that. So that is essentially a very well-documented process and something that's kind of very easy to do.
Yeah, I wanted to bring that up on my screen here. Sorry. So here's for example Linux, you know, and it would give you like wget command, and you have your curl and RPMs and so on, and Windows the same, OS X and Docker and so on and so forth. So there's extensive documentation for that. And when you log into your system, you create a key, and when you create a key, Takipi will show you, the dashboard will show you or instruct you how to install the agent on your local machine.
Great. There are a couple more questions that we can get to. One question is about using reactive monitoring with other build tools, namely Gradle.
Yeah.
What's the situation there?
Reactive Platform should support other. The documentation is very sparse. So, but I know there's Maven, a POM file somewhere. But that's something we definitely should look into and highlight and explain how to get started with that. Because right now it's very hard to find.
All right.
I mean, what basically Reactive Platform is just what it is it's another build. So there would be, the dependencies look a bit different, but basically, and the plugin that you install, the SBT plugin, it rewires the dependencies inside of your build SBT file or the library dependencies. But in a POM file, you can do exactly the same what the plugin is doing, mainly just pointing to the right dependencies. So there's nothing stopping someone from building with you know, Maven user from using Reactive Platform.
Okay, great. There's a couple questions on the inevitable what's coming next, and namely about metrics for futures in Scala and Java 8. Do you have any comments on that, Henrik?
It's definitely on our roadmap, and you know, it's also feedback that we would like to get from you guys. It's like, what would you like to see after this has been released? What should we do next? So that's something we're very eager to listen to the community and see what's the most important thing to focus on hereafter. But definitely futures is on our radar and something that we're looking into.
Okay, and we've got time for one final question, which is related specifically to akka. Does this solution support akka persistence and cluster sharding?
I mean, you'll get metrics for the akka actors regardless of what they're doing, but there won't be any specific information, you know, with regards to persistence or clustering in this version. So it will be just regular metrics for the actors that are involved in whatever you're doing.
Okay. Well, I have one final comment. I'm going to put it in the chat window for everybody. It is a Google group. If you'd like to learn a little bit more about Reactive Platform or ask some questions, that's definitely monitored. Paul and Henrik, thank you so much for your time today. To our excellent audience, thank you very much for all your questions. If you have some more questions that weren't answered, you can email me directly at oliver@typesafe.com, and I will find someone to answer them for you. With that, I hope you all have a wonderful day, and thanks again for joining us.